Hello, my name is Julian Lizano and my partner is Polgarro. We are going to present 5 case topic about MIPS assembly language. I will cover data types, registers, and program structure. My partner will then cover data declaration and load store instructions. Let's start. First, let's talk about data types in MIPS. At the hardware level, data is just a sequence of bits. The meaning of those bits depend on the instruction that interprets them. MIPS supports three main integer size: byte, which is 8 bits, half word, which is 16 bits, and word, which is 32 bits. The word size matches the register size. For real numbers, MIPS use the IEEE 754 standard. It supports single precision, which is the 32 bits, and double precision, which is 64 bits. Character use ASCII, 1 byte per character. String end with a null character. Also, MIPS requires data alignment hardware at even address. Words at multiple of 4. That's all for data types. Now, let's look at registers. Registers are the fastest storage in the processor. There are 32 integer registers and 32 floating point registers. Integer registers go from $0 to $31. Some have a special purpose. $0 always contains 0. $2 and 3 are for return values. $4 to 7 are the function arguments. $8 to 15 and 24 to 25 are temporary registers. $16 to 23 are saved register. $29 is the stack pointer. $31 is the return address. Temporary registers called $T do not need to be preserved between function call. Subregister called $S must be preserved. Floating point register go from $F0 to $F31. For double precision, we use two consecutive registers as a pair. Using register efficiently is key to grading good MIPS code. Next, the structure of a MIPS program. A MIPS program has two main sections. First, .data. Here we declare variables and constants. Second, .text. Here we write the instructions. We need a main labels as the entry point and .global main to make it visible. Labels and symbolic names that represent memory address. They help use reference data and code position. Every program must end with a system call to exit, load 10 into $B0 and execute cycle. That's the basic structure. Now, my partner will continue with data declaration and load store instruction.
Thank you. Now I will continue with data declaration and load and store instructions. Let's talk about how declared in MIPS. A data declaration goes inside the data segment. The syntax is simple. A label followed by a colon, then a directive and value. For integers, we use do byte for 8-bit values, do half for 16-bit values, and do word for 32-bit values. The word is the most common because it matches the register size. For floating point numbers, we use dot plot for single precision and double for double precision. For strings, we use dot ASCII. This directive automatically adds a null terminator at the end to reserve space without initializing. We use dot space followed by the number of bits. Here is an example: a word with value 25, a float with p, a string with a name and the array of 4 integers. Load and store instructions. Now, let's discuss load and store instructions. MIPS is a load and store architecture, arithmetic operation only word on register. To use data from memory, we must load it first and then store it back. For integers, the main instructions are load word or LW copies 32 bits from memory to a register. Store word or SW copies 32 bits from register to memory. Load byte, load hardware, and their using versions. Store byte and store hardware. For floating points, we have separated instructions: load word to coprocessor 1 or LWC 1, load at single precision float, store word from coprocessor 1 or SWC1, stores it. For double precisions, we use I.D and S.D. The address is calculated by adding an offset to a base register. For example, LD double $T0 offset 4 from $SP. The base register points to the start of the structure, and the offset selects a specific element. Important rule: address for word must be multiples of 4. This is a called word alignment and not aligned. Address generate an exception and the program might crash. In summary, load and store instructions are the only way to access memory in MIPS. They use base register with offsets and required proper alignment. To conclude, we have covered data types, register, program structure, data declaration, and load and store instructions. These are essential for writing MIPS assembly programs. Thank you for watching. Goodbye.